This is my continuing series on elementary mathematics. Alright, the first thing I'm going to introduce you to is the circle. Okay, I've talked about the circle once before. We're going to talk about it again. Because all circles have a diameter. And what the diameter is, it's a line that starts from one end of the circumference of the circle and goes all the way to the other end of the circumference of the circle and actually passes through the center of the circle. Let me say that again. You have a circumference of the circle, which is its outermost edge. Okay? The outermost edge of any circle is called the circumference. Okay. And then you have this diameter here that runs from one end of the circumference of the circle to the other end of the circumference of the circle, and it actually passes through the center of the circle. Now, any line that is drawn from the center of the circle to its outermost edge or circumference, as the case is, okay, any line that goes from the center to the circumference is called a radius. Radius! Wait a minute! I know that word! Rays of the sun. Radius. Ta-da! And didn't we say earlier that an angle is comprised of two rays? Yep, we sure did. Okay. So now we have two rays of an angle here. But not just any angle. Okay? Both of these rays start from the center of the circle and they stretch out. Now what does that mean? That the distance from the center to the outermost edge, which is the circumference, okay, the distance from the center of the circumference is going to be the same no matter where you draw that radius. Now that's very important. Why is that? Because all the radii, and by the way, the plural of radius is radii. You know how words will have a singular and a plural form? Same case here. Singular, radius. Plural, radii. All radii of a circle are exactly the same size. How do we know this? Because I just said, if you draw any line from the center of the circle to the circumference, no matter where you draw it, okay, if it draws from the center to the circumference, it's going to be exactly the same size. That's how we know this. Why is this important? Because it directly leads to Euclid Book 1. Okay? Euclid Book 1, proposition number 1, talks about this. Ooh. This is how you start duplicating lines without a ruler. Oops. You mean you don't need a ruler to draw a straight line? No, you don't. You can duplicate lines without a ruler. All you need is a compass and a straight edge. Why do you need the compass? So it can draw perfect circles. Why do you need a straight edge? So that when you draw your line isn't crooked. That's all. You don't need a ruler to duplicate lines. If you use Euclid Book 1, Proposition 1, you can duplicate lines. Well, you say, well, wait a minute. We know what a circumference is, a diameter and a radius and radii and all this other stuff. But how do we duplicate the actual lines? Okay. You have to have one more piece of information in order to duplicate lines. Just one. Okay. This here is no ordinary triangle. It is an equilateral triangle. That means that the lengths of all three sides are exactly the same. So this would be 1 inch, 1 inch, 1 inch. Or 2 inch, 2 inch, 2 inch. Doesn't matter. As long as each one of those sides are exactly the same size, then bam. There you go. Now that leads into Euclid Book 1, proposition number 1. You say, well, how does that work? Because if you have two circles and they are exactly the same size, and the circumference of one circle passes through the center of the other one, you can draw the radii of those circles and form an equilateral triangle. And by doing so, you can duplicate the lengths of any line. That's how that works. This becomes vital to mathematics. Because once you start duplicating triangles, because you can now duplicate lines, so if you can duplicate lines, you could duplicate triangles. If you can duplicate triangles and you take two triangles that are exactly the same size and you push them together, you can form a square. You can even form rectangles because of this. Do you see what I mean about them not teaching elementary mathematics correctly? Don't you think you learned a few things from me? Now, I will continue this series on elementary mathematics at a later date, because I have some other things I want to teach in the next day or so. So I'm just going to leave this for right now. I will teach you more in a future video. I thank you for watching. As you can see, this has been in high def. I figure you should start elementary mathematics with high def, and then we can go on from there. In the meantime, you know what? I think I'm going to teach one more video tonight. Just one. In the meantime, I will tell you more in a future video, so stay tuned.